Hello everyone, in this video we will solve the question which is majority element. So this question is asked in many interviews like for Amazon, Facebook, Google, etc. So this is an easy 11 question. So let's see what's the question all about. So given an array of size n, we have to find the majority element. So what is a majority element? So the majority element is an element that appears more than n by 2 times. So n is the length of the array. So basically in this question example, if we see the length is 3, so 3 by 2 is 1. We have to take the floor value. You can see this is floor value. So 3 by 2 will be 1. So we have to find an element who occurs more times than 1. So here you can see 2 occurs 1 time, so it won't be the majority element, but 3 occurs 2 times, so it is more than 1. So that is why it is a majority element. So you see if you see in this array, so it is of size 7, so you can see 2 occurs 4 times, so 7 by 2 is 3. So that is because of the floor value. So 3 of 2 occurs 4 times, so which is greater than 3, so that means 2 is a majority element. So let's find out how to solve this question. So if you are asked this question in an interview, so you should start with the brute force solution. So brute force solution is easy to first of all create. So let's see. So if you are given this array, basically this example as we saw, the answer is 2 because the length is 7. So 7 by 2 is equal to 3.5, which will be taken as 3. So 2 occurs 4 times, so which is greater than 3. So that is why 2 is the majority element. So in this solution we have to traverse for every element, and we will again run a loop. If we are at 2, we will run a loop to traverse the array. Then we will run a inner loop to count the number of elements that are occurring, and we will check at any point if the occurrence of the element, we will maintain a count variable, is greater than n by 2, then it will be our majority element. So this solution will take O of n square time, because we are basically traversing 2 times. For every element we are traversing 1 time, so it approximately equals to O of n square. So but it will be taking only constant space, because we are only maintaining the count variable or the element variable, not the array or such. So this will be a good solution, but interviewer will ask you to optimize the solution further. So if you know hashing, you can tell him this solution, that if we basically you can solve this using hashing. So what is hash table? So you can say hash table or dictionary in Python, or hash map or hash table, or all the same in C++ and Java. So the hash table basically consists of key and value pairs. So key is our element, so we will traverse through this array, linearly traverse through this array, and initially our hash map will be empty. So we will check if 2 is in hash map. So no, it is not there. So we will add 2 as a key and its value as 1, because it was not there first of all. Now if we again get 2 on the next index, so we will just increment the value at the key 2, so it will become 2. Then again we will see 1, so 1 is not in the hash table, so we will write 1 here, and similarly we will keep counting the variables, the number of occurrences. So this will be our occurrences. So at any point we will check if the count of the particular the value of the particular key becomes greater than n by 2, so that will be our answer. So we can just break from the loop and print our answer, because we are told that only one element will be there whose occurrence will be greater than n by 2. So this approach will be optimized using the time, but the space complexity will decrease. We will require more space because we are using hash table, so it will be O of n. If in some hash maps, so the time complexity becomes n of log n, so in sometimes it is constant, so it will depend. So you can tell him. So now he will again tell you to optimize the solution, and we will first of all talk about one more solution, which is using sorting. So in this you can optimize the space, but you can give up the time complexity. It is basically using sorting. So you can see sorting takes n of log n time, so it is of taking that time. So you can see in this array, if you sort the array, we will get these elements. So basically if you sort the array, they are more than n by 2 times, so it is majority element. So if for this example you will see, if we sort this, so 1 and 2, so you can simply print the middle element, because the majority element will be coming n by 2 times, so it will be greater than it if we start from the starting. If for example if 1 is a majority element, so it will start from here. Now you can see it will obviously pass through the middle, because it is greater than n by 2 times, so it will occur at the middle plus covering the another indexes. So here 2 is the majority element, so you can see it starts from the middle because it has to be greater than n by 2. So n is the size of this array for being greater than n by 2. As we have sorted this, so they will occur continuously. So you can see it will be at the n by this middle element also will be the middle element will be our majority element. So you can also tell this solution. So it is of n log n time and over constant space. So now let's see the most optimized solution which the interviewer will expect you to tell him. So in this basically it is called as Moore voting algorithm. Sorry for the wrong spelling. So in this solution, basically let's see, we have to this is the pseudocode. I will explain you the intuition afterwards. So let's first of all see the algorithm and run it on this. So first of all, we have to initialize two variables. One will be our count and second will be our element variable. So element will be our output, the element we have to store, and count will be our occurrence of the element. That we will see how we will maintain that. So basically in this, you see if we are at this index, so we will increment the count. So count will be our 1. So if the element is not same, if this is 3, so we have count 2 as they are same. If the element is same as the previous element, the count will increment. If the element is not same, the count will decrement. If we are here at this index, the count will be 2. So if we are at 4, so count will decrement. If we are 2 it is not equal to our element, so the count will decrement. So that's why it using that like thing. So you can see if the count is equal to 0, we initialize the element to this value. That is basically a reset point. So if the element is equal to the element, current element is equal to the element that we have stored, that we are thinking of as a majority element, that may be a majority element, we will increment the count. If it is not so, it is not equal to the element that we have stored, we will decrement the count. So let's run that algorithm on this example. So I have maintained a count variable. Okay, this will be a count variable. I will write it as C, and this will be our element variable. So you can see, so now if we start from I will always start from 0 to 8. So it will run from here to here. So if we see, first of all, our count is 0. So you can see our count is 0. So this condition will be true. So you can we will set the element as this. So we will this may be our potential element answer, the majority element. So let's set the element to value 3. So yes, it is 3. So now we will check if element is equal to this will run. So element is equal to the current index value, so that is 3. So now we will increment our current. So current will be 1. So now I will increment, I will come to this point, and now we will check the value is 3. So current count is equal to 0. No, count is not equal to 0. So that is not our reset point because elements are same. So now we will check if element is equal to the array of current index. So yes, you can see element is 3 and this value is also 3. So they are equal. So we will increment our count. So you can see we will not enter into this condition. Now let's increment the I. So I will come here. Now you can see 4. 4 is not equal to count is our, first of all, our count is not equal to 0. So count is equal to 2. So it is not 0. So this is not our recent point. So now we will check element is equal to the current element. So no, it is not equal to that element. So we will be decrementing the count variable. So we will decrement this. Now I will be incremented. As I told you, if the element is not equal to the current value, so we will decrement the count, otherwise we will increment it. Now we will see 2 is not equal. Now our count is equal to not equal to 0. So element so this we will then check this condition. So element is not equal to the current value, that is 2 is not equal to 3. So now we will again decrement our count. So count will become 0. So now we will increment the I. So now you can see, now at this point count is 0. So we will enter into this condition. So we have to reset our element. So because this element is not our majority element till this till this sub array. So now we will change our element to 4. So this is our potential candidate for being a majority element. So now we will check 4. So yeah, we will enter into this condition. Count will be incremented. Count will become 1. Now again I will be incremented. So now you can see element is again, so count is not 0. So we will enter to this condition, that is element is equal to the current element. So we will increment the count. So now again I will increment. So now again count is not 0, but the element is also not equal to the current element. So now we will enter into else condition. So we will decrement this. Count will become 1. Now I will again increment. So you can see now our value is 4, which is equal to the current value, and the element are equal. So now count will be incremented. So now again I will be incremented. Count is not 0 and element is also equal. So now our count will increment to 3. So now you can see we have got our majority element. You can see our output is correct. So 4 is our majority element. Here you can see the length of this array is 9. So 9 by 2 will be 9 by 2 will be 4. So this element 4 occurs 1, 2, 3, 4, 5 times, which is greater than 4. So this is our output. So why this algorithm works? Because you can see till this point, the intuition behind this is, you can see at till this point our index got reset, our count variable got reset and element got reset. You can see 3 and 3, the count got incremented first of all, then it got decremented when the 4 and 2 came. So here you can see the majority element and the minority element, that is 4 and 2 are cancelling out each other. You can see they cancel out each other. So here was here no majority element was there. So if we will be sure that after a certain index, so you can say a prefix, after a certain prefix there will be a suffix where the majority element will be more than the minority element, because we are told that the output, our majority element is the element whose count is greater than n by 2. So it should be greater than n by 2. So to occur n by 2 times, greater than n by 2 times, it has to be in more number than the minority element at the ending of the array. So you can see at this point, you can see the 4 by 4, our count got incremented to 2. Now this 2 came, but it decremented our count to 1. But here again our count got incremented. So you can see at the end. So for this example also, let's see this array. So you can see here also our first of all, if you see this array, so at this point our the count got incremented to 2, but the 1 at this point our count will get cancelled out to it will become 0 and our element will reset to 1. But at this point you can see the majority element is 2, but it is cancelled by the minority element because they are also 1. So that's why if you see in the ending array, you can see ending suffix of this array, so 1 will be incremented, the count will be incremented. We will think that 1 is the majority element, but afterwards 2 will cancel out the 1, the probability of 1 being a majority element. You can see 2 occurs 2 times, which is greater than 1 time that 1 is occurring. So that's why you can see this algorithm works. So now let's dive into so this algorithm will take O of n time, because we are only linearly traversing this array, and it will take constant space because we are only maintaining the 2 elements. So sorry guys if you don't understand the intuition, because I am also not good at explaining. So you can refer to more articles about that if you don't understood, or you can define back the video. So let's dive into the code and see how we can code this. So I have written the code in C++. So let's find out. So this is the code. So basically we have given an array, we have been given a vector of integer type. So we have to initialize our result and element. Result will be our the count variable that we are maintaining, and element, this will be our count variable, and element is the result that we have to return. So this is not our result, this is our count. So this is our count. So let's see. So first of all we have to iterate from 0 to size of the vector. So now we will check if the count, or you can see this result is equal to this count. So if it is equal to 0, that means it is our reset point. So we will change our candidate for the majority element, for being a majority element. And here you can see I have, as I have explained the code, it is similar. So we will check if this element is equal to the element, current element is equal to the element that we have stored, we will increment our count, otherwise we will decrement our count, and at the end we will return our element. Basically in this algorithm, if we are given that we will have a majority element, if we don't have any majority element, if you should ask the interviewer, are we sure that we have a majority element? If we don't have, then we will again run a loop, and the element that we have got, for example, if we have got the element, there are no majority elements in this array. For example, there is no 4. So if you check, if this 4 is not there, if you will if you have got this answer as 4, so you will again run a loop through this array and traverse and count the occurrence of this 4, the element that we have got. So if it is greater than n by 2, then it is a result, otherwise the array don't have any majority element. But here we have given that the majority element exists. So let's submit the solution. So I will also share this code in the description, so you can download it from there or check it for your reference. So you can see it is faster than 84% of solution and 90% of the space complexity of other solutions. So now let's see the Python code. So in Python we are given a list. So I have initialized a count and element variable. So we will this loop basically is this, we will traverse through this list, and this I is the element in the list. So we will check if the count is equal to 0, we will change our element, otherwise we will just increment our count, or if it is not equal to the element, we will decrement our count, and at the end we will return the element. So let's submit the solution also. So you can see it got submitted. So it ran 80 faster than 87% 808% of solution, and it took less memory than 82.23% of solution. So I hope you understood this, guys, and do like this video and subscribe this channel for more such videos, and I will keep making this videos for the interview preparation. So do like this channel and subscribe this. Thank you.